Hi, welcome back to my physics channel. Um, Today we're going to be talking about forces and motions. First, we're going to talk about net force, then about motion, then friction, and for last, acceleration. So let's begin. Let's select the net force. Oh, the net force. Uh. Uh. The net force simulation. So here we see that we can put like two teams pulling the rope. Each side applies a force. So the net force is the total force after combining both sides. So let's see. Let's add this guy right here. And well, he's applying 100 newtons to the right. And then we're going to apply the same one but to the left. So we can see if we click go, if you um if you subtract 100 from 100, your result is going to be zero. So it is actually on equilibrium. But let's pause it and then let's apply a bigger um humanoid. Yeah. And as you can see, now there's 250 newtons going to the left and only 100 newtons going to the right. So if we can remember, we can see this like as a Cartesian plane, si se dice así, bueno. And if if you're going to the right, it is going to be positive, but if you're going to the left, it is going to be negative. So you have 100 newtons to the left, to the right, sorry, and 250 newtons to the left. So you're going to subtract 250 to 100, and you're going to result with 150 newtons. So that's how you actually use this. You can see the speed, how the speed increases. Um, and yeah, let's give this a try. So as you can see, the force, the net force is, oh, right. Oh. I'm so sorry. The net force actually goes to the left because we have more applied force from that to that side. So yeah, let's um let's try again with these little ones. So as you can see, there's 200 newtons going to the right and 250 newtons. I'm so sorry, going to the left. So so if we give this a try, it is going to still go to the left. But what is going to change is the speed because, oh my God, I'm so sorry, but there's like a child party out my house and they're playing some they're playing some songs I find funny. But yeah, you can see it is going to be 50 newtons going to the left. So as a consequence, the speed is going to be slower, and I say, oh my God, and the acceleration is going to be slower, but it is going to still go to the left. So that's with the, well, um, now let's connect it to the Newton's law. Newton's laws. Yeah. Um, well, this shows Newton's first law that if the force is zero, motion doesn't change. As you can remember from the beginning, oh my God, let's add these two big boys, and then the sum of forces is zero, so in consequence, there's going to be no motion, right? So, and it also is connected to the Newton's second law because a bigger net force causes a bigger acceleration. So let's add these four guys. You can see that there's 200 newtons pulling to the left. Oh my God. So yeah, That's what happens with the net force activity. Now let's move to motion. Um, wait, let me. Oh my God. That's, I'm so sorry, guys. I'm kind of sick again, but don't worry, I'm okay. So let's go to move to the motion. So when I apply a constant force, the object doesn't just move at a constant speed, it actually keeps speeding up. So let's see that we're applying 200 newtons. So there's an applied force going to the right, and it is going to keep moving. Look, you see? It is obviously going to deaccelerate. Let's see the values here. Mass is speed. Stopwatch? No, we don't need a stopwatch. So this thing right here, this box, weighs 50 kilograms, and it reaches a speed of 40 meters per second. Oh, it is not going to, yeah, it won't stop because there is no friction, right? Yeah, it actually keeps speeding. So a force doesn't cause a constant velocity or speed. It causes an acceleration. So let's yeah. Oh, how can I bring this? Oh yeah. So this demonstrates Newton's second law. Let's apply this little boy right here. So now it is actually 80 plus 50. Now it's actually weighing 130 kilograms. So we need a bigger applied force to move like the last exercise, well, not the last box moved to a speed of 40 meters per second, if I remember. So now we're going to need a bigger force to cause the same acceleration. So more force, more acceleration, and more weight. And if you use the same weight, no, the same force, if you apply the same force but a different weight, the acceleration is going to vary. So let's see. 100, oh my God, oh, wait, no, 500 newtons. So watch. It, um, it keeps moving at a constant speed because there's no friction. And yeah, it causes acceleration, not a constant velocity. Yeah, perfect. Now let's move to friction. Um, well, friction is a force that always acts against motion. That's why I told you here that it is going to keep moving because there's no friction. But now let's see in here. When I increase the friction, oh look, oh, okay, this is a great example. But let's add this. As you can see, imagine you you are on ice, like on really clear ice. You can you have no friction. There's no friction in ice. So when I apply non-friction, it's ice because it's like a um surface where there's no friction. But now when I add like friction, there's like this pointy, or I don't know what it is. Um things right there. And yeah, this is what applies friction. What, yeah, you understand. So let's apply lots of friction. Well, no, let's not apply friction. So 50 kilograms again. I'm going to move it. And look, it is so easy. And it is going to keep moving. But now we're going to reset this all. Oh, wait. And we're going to add friction. Just a bit of friction. And we're going to apply the same force, 50 newtons. 500 newtons, sorry. It is taking more time to accelerate to 400 meters per second speed, and it is decreasing its speed. Why? Because friction acts against motion. That's what I was telling you um uh, uh, before. So yeah, it will actually cause a deceleration and it will stop completely. Now let's try it with let's try it with the stopwatch. So now we're going to apply 500 newtons. Oh, wait. Oh, I'm wait. Nah, I'm so dumb. So why is not let's, let's count the time. Well, this is not going to accelerate. Yeah, what am I doing here? Well, we can see, I'm going to add the stopwatch. So you can see the difference in the acceleration and the movement. So with non-friction, let's do it like this. And then, wait. So as you can see, it reaches a time of approximately 4 seconds to reach a speed of 40 meters per second with no friction. Now let's add friction. The friction force is about 93 newtons. How do you get the friction force? Um, Wait, oh yeah. You're going to multiply the friction coefficient, the kinetic one, if it's currently moving, and the normal force. How do you get the normal force? With the sum of forces on the y-axis. So now, I didn't know I could do that also. Hoo, hoo, hoo. Oh my God, you saw that? That was actually insane. I didn't know I could do that. Wow. Well, I mean, you saw it. Wait. I'm going to let me accelerate the box again. Yeah. And let me now do this. So, as you can see, it is applying a force to the left. So it is going to be actually faster to stop the box from moving. You understand? Yeah, I know you understand. And now, with friction, oh, I'm so sorry. I forgot to take the oh, oh, this is actually so insane. Wait, how can I? Oh, yeah. We're going to apply 500 newtons again. And no, I don't want friction force. I haven't even started. Oh, but there's already a speed. Wait. Let me reset all this. Oh, wait a second. Oh, yeah, I forgot to say something really important. Um, when you need to move something, like you need to move this box, your applied force needs to be bigger than the friction force to make it move. So let's apply here. Wait, here. If I apply a force of 123 newtons, it is not going to move. Look, it will stay still. Why? Because of the friction force. How do you get the friction force? Um, Multiplying this for the, wait, I mean, you need the friction coefficient and your normal force. So the normal force will actually be, well, wait, uh, 490. So that's your normal force. And we can suppose that the friction coefficient is, wait, hmm, I think I did my cal oh my God. Oh my God, is the I need to hurry up. Okay, so now, yeah. Well, let's stop with friction. Yeah. So, acceleration. Um, let's apply all of this again. This is like the wait, I didn't no. This is the like all of what we saw early, like all of this ¿cómo se decía junto? Wait, wait. Together. Yeah. I'm so sorry, I forgot. So, let's apply, let's pause this. Oh, there's no timer. Well, that's a shame. So, let's apply a force of 500 newtons again. So the friction force is again about well, let's add a lot of friction. Now, the friction force is about 245 newtons, and the sum of forces, it's giving us 255 newtons to the left. So, here we can see how acceleration depends on force and mass. If I increase the force, the acceleration increases, like here. Let's do it again, like this, the past one. And if I increase the mass, like as we were seeing early, the acceleration decreases. This is literally um F as a force, it's equal to m times a, like the formula, like the formula we use to get a force from Newton's second law. And the third law, whenever I push an object, it also pushes back with an equal so sorry, with an equal and opposite force. Look, it is actually so slow, but if I take this guy out, it is going to increase acceleration faster. So yeah, that's how you can use this simulator just to, you know, to learn. And yeah, it's actually so interesting. You can do much things, and yeah, it's so interesting. You should try it and tell me what you think. Now, thank you so much. Hope you and like the you 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 enjoyed the video, and yeah, see you later.